Hey, what's up folks, and welcome back to another Layer by Layer. In today's tutorial, we're going to take a look at the new 3D package generator inside of Fusion 360, but also walk through creating a PCB out of Eagle and bringing it into Fusion. So let's go ahead and jump into that. So what I'm going to start off with is this is the PCB that we're going to make today. So this is the Adafruit PCF8591. It's a ADC to DC breakout. And what we're going to do is we're going to download the Eagle CAD files from GitHub. So if you click on this link here, this is the Learn Guide, by the way. This breaks down all the pinouts, what the sensor does, and the libraries that you can use with it. In the Downloads folder, that's where you're going to find the links to get the datasheet and the Eagle CAD files on GitHub. Very, very cool. And here's some screenshots of it as well. So we're going to be using Fusion 360 and Eagle CAD. So here is the GitHub link. And to download everything here, under the green code button, you can click on Download Zip, and that'll download the board file and the schematic file. Very nice. So once we get those, I'm going to go ahead and open that in in Eagle. I'll start off with the board file first. So I'm going to go ahead and open this up in Eagle. And this is what it looks like. So this is what the board is like. I'm going to click on the Manufacturing tab. This is going to give me a nice render of the silk screen and what the traces and stuff look like. There's a lot of values and names that are being rendered on top of our silk screen. So one of the first things I normally do is to change those up and clean them up. So go ahead and close that tab, and I'll open up our layer settings so we can see all the different layers. If you hold down Shift, you can do like a group select, and then you can hide those set of layers, which is what I just did now. The next thing I'll do is reveal the layer 25 all the way through layer 28, and those are all the values that they're not being used in this particular case. So and again, they get rendered here in the Manufacturing tab in our little preview. It's going to get, if I were to export this to Fusion right now, all of that stuff would show up like this. So I need to clean that up. So the way to do that is I'll use my group tool and make a marquee selection or a group selection, and then just drag and select all those. Then I can right click on one of them, say delete, and then the second time I right click on one of them, I get this delete group. So I can click on that, and that deletes the whole group that we selected. So now inside the Manufacturing tab, all that stuff disappears, and now all I'm left with is just the silk screen graphics and text that is in there. So it really is going to depend on how your PCB is set up, but in this case, it uses the proper layers 21 and 23 to show the graphics. So here's what everything looks like all at once. It's a lot of stuff, but if we look at the Manufacturing tab, it's the right way it's supposed to look. So the next things I'll do is, like, you can change the silk screen under the cogwheel. You can change the color of the silk screen or the solder mask. The real PCB is black, so why not change it to black? And then I'm not a fan of the copper color, but you don't have to do this. I just like to change the color here to something a little bit more to my liking. You can even see the traces here show up really nicely as well. So now that that's all set up and cleaned how we want, I can now open the Fusion 360 tab, and you get two options here. Do you want to link it to an existing design, or do you want to create a new one? I'm going to create a new Fusion 360 design, hit next. Then you want to choose where you want to save it. I have a particular folder for it, so I'll save it in there. And then I'll say just a comment here, first comment, whatever. First try and push that out. So now what Fusion is going to, or what Eagle is going to do, is to push out this data to Fusion, extrude it out, and create the silk screen graphics and overlay it there. And at this point, if you do not have a managed library inside of Eagle, you don't have to worry about it right now, but at some point, it's really going to be nice to map all of our 3D parts to Eagle libraries, to the parts and the footprints in the Eagle library. Right now, we're just kind of doing everything a little bit manually. So that's the workflow that we're working with right now. So just keep that as a side note. Eagle has told me, all right, it's now in Fusion. Go ahead and check it out. So hit OK. This right here, the sync to Fusion 360 window, just lets you know if any updates happen. There is some linking that you can do here, but we're kind of manually doing this. So I'll hit close. And now inside of Fusion, I'll go ahead and open my data panel, and I should get, yep, the data in here has been updated. Hit refresh. And then if I scroll down here, I should be able to see our new PCB, or PFC8590. So let's go ahead and open that. So here it is. So okay, so these are the components that do not have any 3D models associated to them. It'll just give you these kind of thin blocks here as placeholders for all the different things. But because our libraries tend to use logos and mounting holes as components, as parts, they get rendered as such. So here's what the structure looks like. Let me close the data panel. It says PCB component. So if you open that, you can see all the different components that are in here. And what I tend to do is kind of hide some of these things, like the fiducial marks. We can hide those. I hit the V key on my keyboard, by the way. That hides and shows stuff quickly. The mounting holes, I can hide those. Adafruit logo is a 3D item. I'm just going to hide that. That gets showed as a part of the silk screen here. Some other stuff like the PC revision code, I like to hide that. Let's see, these solder jumper arrows, these are also treated as 3D objects, but they don't need to be, so I'll just hide that. These 1x05s, these are supposed to be headers. I just hide those. I'm not gonna use the headers in this design. I just want the PCB and the components. So with all those items hidden, oop, there's one that got slipped through, this fiducial. Now we're just seeing all the 3D models. So the next steps is, there's some more here. There's these Stemma GT logos. There you go. That looks great now. All right, so that's looking good. I want to show you guys how you can use the 3D package generator to create this chip here. So back over into here, the chip is the PC8591. That has its own data sheet, so we can open that, and that's this right over here. And this is the page that tells me the package type. It's an SO16 type of package, and this gives me a technical drawing and some labels, and then down here in this table it gives me the dimensions for each unit or each label. So that I'm going to be able to use these numbers and the package generator to create a 3D model of this item here. So library IO is normally where I would create my my chips. If I couldn't find one on GrabCAD, for example, I would generate one through here. So this is from Autodesk. This has been out for a few years, and I have done a library on using it. But now you can do all this inside of Fusion, which is really cool. So let me show you guys how I do that. So I create a new tab here, and there's kind of two ways to do it. There's sort of a sneaky way, and then there's like the official way. I'm going to show you how to do it the sneaky way first. So using the S key will bring up the design shortcuts, and then from here I can just type in pack, and then you can see I have the 3D package generator. So I'll click on that. That brings up our little package generator window. So I can move this around, and what I'll do is I'll look for the type of chip that we're working on. It's a SOIC, so down here is the SOICs, right? I probably passed, there it is, the SOIC or the SOP. So I'll click on that, and we get a nice icon with labels that are very, very similar to our data sheets. Let me go back to the data sheet. You can see here we have D is the length of the whole chip. If we go down here to the table, D1, capital D, is 10.5 for the maximum value and 10.1 millimeters for the minimum value. So in here, I'm going to go, well, first of all, let's update the pins. It says there's 20. I actually need 16 because this is a SO16. There are 16 pins. And then I want to update the label D, the unit D, which is the length of the chip. So that here is also D. You just want to make sure that they're the same, because sometimes they're not. So this, I just need to change this to 10. And I'll also change the minimum to 10. So I'm just going to keep them the same. That's really all I need to change, is just the length of the thing and the chips, and the pins. You can look at all the other ones, make sure your pitch is the same and all that, but I've already kind of done this, so just to save some time, all I really had to do was change the number of the pins and the total length of the unit D. So I'll hit Update Preview. I'm going to get an error because, well, this is the sneaky way to do it. Normally what you do is you create a new library and then you create a new package, and then that would create a footprint for Eagle. But in this case, I just want the 3D model, not caring about the footprint right now, because I can already have the footprint. I just need to create a 3D model of it. So that's what this error is. And I'm just going to hit OK. Fusion's going to execute like a whole recipe, essentially, down in the timeline. You can see how it created this 3D model, and you have full control over the model. You can change the colors. You can step into the sketches. And that's really interesting. Just from a side note, like if you want to know how they draw these things, you can just look at how it's all being extruded and how patterns are working into this. And if you open up your user parameter window, you'll notice that the units are pretty much one-to-one here. Like parameter E, capital E is also parameter E over here. Just note that these are not like linked. So if I were to change some of these values, the values here in the package generator won't update. So there's not really a link going on there. So you probably want to stick to just updating this stuff here. All right, so now that I have this, I need to bring this into our actual PCB here. So to do that, right now, again, this is sort of the manual way to do it. So I'm going to double click on the PCB feature in here, and that's going to bring me into like the PCB sort of work area. And this is where you can start replacing some of these components with actual 3D models. So for example, this one right here, the SO16W, right click and say replace component body. That will bring up a window, and it's looking for a step file. So it doesn't quite work with a Fusion 360 file yet. So I'm going to hit cancel here and actually export out a step file out of here. So I'm going to show you the kind of the wrong way to do it. That way I can show you how to fix it. So as it is now, I would assume that you would right click on like the main assembly here. We haven't saved this out, by the way. So I hit right click on that main, like the root of our document here, hit export, name this SOIC16. We want to make sure that the file type is a step, and then make sure again that it's a step, because a lot of the times I'll accidentally export like a SMT and be upset. So make sure it's a step, name it what you want, and then you probably want to save it somewhere where you want it, save it. In my case, it's this folder. Hit open, and then again, you want to have that saved to my computer checkbox there, which should be checked. Now we can hit export. I'm replacing something already there, which is okay, because I'm showing you how to do it. And now, if I try to bring that in, so open up our PCB here, and then right-click on the SO16 replace component body. When I try to import that, it does something, but it doesn't actually take. It doesn't like it. So what I found is that you actually want to select this component. It says model. You want to make sure that. And I think what's going on is the tool doesn't like importing multi-nested components. I think that's what's going on. So I'm going to activate the model component, right click on that in the browser, and then hit export. So essentially I'm exporting the stuff in the model component, and it even names it as such. So I'm going to rename that to SOIC16. Make sure it's a step file. Okay, double check it's a step file, and then save it in the same spot there, export. It already exists, hit yes to overwrite it. Go back to the PCB, right click on that item, replace component body. Now let's select it again, and hey, it's there. That's our 3D model, excellent. But you'll notice that it's not oriented correctly. Now, Fusion gives us some tools to orient it, but as you can see, the pivot point can't be changed, meaning like if I just wanted to rotate that with the pivot point being in the center, that would have fixed everything with just that single rotation 90 degrees. But the pivot point's like at this corner, so it's a little bit difficult to kind of shove this into place. A lot of the times I'll do this But you kind of don't have to now that you have these tools inside of Fusion. So you can massage this all you want, but I'm going to hit cancel and undo, Control Z. So I undid that. And what I'm going to do is inside here, I'm going to just rotate this model and then export that again so that when I bring it back in, I don't have to shift it or anything like that. I already know that it's off by 90 degrees. So I'm just going to go ahead and do that edit here. So with the model active, let me open the bodies and do a shift select on all of these bodies. I'll use the move tool, which is M, the hotkey is M. And you'll notice that the pivot point is like over here. I need it to be in the center. So there's a little button here called set pivot. Click on that and then roll over to the center. It'll actually snap to it. Click on that. Then you have to accept it and set done with the little green checkbox. And now you can actually move this 90 degrees. Whether it's a positive 90 degrees this way or that way, you'll have to double check because I actually forgot which is the right orientation, but let's just say it's positive 90. I'll hit OK. That now is an item here in the timeline. So that's just kind of a side note to know that that is an item in the timeline. So now I'll right click on that model component, export. Let's rename it. And then change the file type from F3D to step. And then make sure it's in the spot that we want to save it to. Hit export, replace it. All right, now let's give it another try. So back over to the PCB, right click on our item and replace component body. So let's go ahead and select our SOIC 16. And there it is. It's like right where it needs to be. How excellent. And it's even in the right orientation. Sweet. That is, I mean, it's the right orientation. So that's cool. So that's how you can use the package generator to generate a fairly complex 3D model and have full control over it. And just some things to note, like what happens when you try to import it in and it doesn't work. It's probably a step file that has like multiple components in it. So that's interesting to note. I guess the other stuff is like these caps. Let's go ahead and map those. I kind of have these already made. I have like a dedicated folder where I have all my components, and I have created those with library IO maybe a year ago. So I've been, I just kind of reuse these components that I already have, and they're kind of already, some of them are oriented correctly, others aren't. I'll give you an example, like the JSTSH connectors. I have 3D models of them, but I haven't actually kind of fixed them. Like I haven't fixed the orientation of them, so I still have to come in here and fix that. So let me show you how to do that one. This is a model that I think I downloaded from the manufacturer. A lot of the times manufacturers will offer step files of their products, which is great. So I got this one here, the JSTSH4. That comes in like this. It is in the wrong orientation. So what I tend to do is just rotate it 180 degrees, move it this way, and then bring it down. And sometimes you can just get lucky and not have to manipulate it too much. And that applied to the other side over here because we're just using the same one. And that looks nice there. Let's go ahead and do this resistor over here, replace component body, go to my source folder, and then look for our 0603s. Those get added in there. The orientation's already set up nicely, so just hit OK. And because I'm using two of them, they both get added. All right, what's another piece that we want to do? The chip LED. The chip LED is right here. It's actually also an item that you can create in the package generator. And that's really cool, but I don't need to use it here. I'm just showing y'all that you can make one, which is really cool. It even has like the attributes for emitting light, so you can actually render out photos that have like light being emitted from this. But I already have that, so right click, replace component body, go to my source. Boy, I wish Fusion remembered this folder. And then I think it's just called chip LED, and it's a 0603. I got a green one here, so I'll just hit OK. The orientation is already set for me, so that's nice. Hit OK. And then the last stuff is these res packs. Interestingly enough, there's also a res pack generator. So again, let me show you the package generator here for the res packs, the chip array anyway. And there's different types of it, but I've already gone and made these, so I'm just gonna use what I have on hand. So replace component body, go to my source folder, and then search for res pack. It's a 4 by 0603 footprint. And these are, not oriented correctly, unfortunately. And these kind of get, they get a lot of, I'm just gonna move it like this, just for the sake of time. It doesn't have to be perfect, but close enough. There you go. It's nice and flush with the surface of the PCB, so that's nice. Anyway, I got those in there. I think that's everything. All right, so let's say we're done, and you got to hit the finish PCB button so that you can get brought into your regular workspace. And then I don't like the color of this blue, and so I'm gonna change it because they're really black. So I'm gonna pick the blue color and just make it black or dark gray. And yeah, old materials cannot be removed from the document, possibly because it's a default material. Sure, still did it. So that's how the workflow is to kind of manually set these components to your freshly imported PCB from Eagle. But hey, I think folks that use KiCad, they can use the package editor to create these models, export them out as a step, and then bring them into their own tools. So that's a really fun thing. There is some more, I think, work that's going to be done, like more packages are coming. That's really cool. I'm kind of missing the LGA packagings, but hey, you got some great ones to start off with. But that's kind of the workflow. Eventually, what we're going to do is start mapping all of these components to the Adafruit Eagle library. That way, whenever folks are designing a PCB, the models will already be mapped. So when I export it to Fusion, all of that stuff will already be in here. So the goal is one day when we create PCBs, we'll be able to create a 3D model at the same time, which is like the ideal goal that we're getting towards. But there you have it, folks. That's how you can create, that's how you can use the package generator in Fusion 360 to make some awesome models. Let me guys know what you think. Is this a workflow that you guys are thinking about? Have you made the dive and started using managed libraries? Let me know. Very cool. So thank you guys again so much for watching. I'll see you in the next one, but don't forget, stay safe out there, and it's up to you to make a great day. Bye, folks.